Hi, this is George Fairbanks. Here we're going to talk about technical debt or original technical debt. And the reason for that is the way we use the term technical debt today is quite different than the way it was originally written about by Ward Cunningham. So it's worth taking a look at what he was talking about and seeing how relevant that is for us today. So today we use the word technical debt to mean bad stuff. And I mean that in the broadest possible way. Like people say, there's some ugly code that somebody wrote over there, that's tech debt. What about code that was written by a novice who just doesn't have the skill to write great code? That's tech debt too. What about I've got a big deadline coming up and I'm going to take some shortcuts that I know are not going to work in the long term? That's tech debt too. You name it, it falls, if it's bad, someone's called it tech debt sooner or later. So the surprise is that when Ward Cunningham originally coined the term, he was using it in a very positive connotation. He was saying that the idea behind tech debt is that when you follow an iterative process, inherently your ideas get ahead of the code that you wrote yesterday. So if you were following that idea of a skateboard and then a bicycle and then a motorcycle and a car kind of thing, you're building the systems in an iterative way. The technical debt occurs when your mind has moved on to the next phase. Let's say you're working on a bicycle and you're looking at the code and it includes all these ideas from when you were building a skateboard, okay? And so that divergence of those two things, that's what the original tech debt was. It's still a little bit unobvious why he thought that was a good idea, so it probably is worthwhile that we dig into that a bit more. So, who is Ward Cunningham? I mean, this is a pretty accomplished guy here. If you've ever used a wiki, you can thank Ward. He invented the very first one so that he and a bunch of his buddies could chat about software development practices, specifically OO and patterns and so forth. He's one of the very first extreme programmers and was behind the Agile Manifesto as well. So he was really there when a lot of the important things that we take for granted now were invented, or he was the guy that was inventing them. He's written about technical debt twice. First was a 1992 experience report where he laid out the basic ideas and was connecting it to iterative development. And then later, actually many years later, in 2009, he was reacting to what he saw the community taking the word technical debt as, and he was trying to steer back on course and make some course corrections. So from now on, I'm going to show you what he thought technical debt was using his words. He said, "We believe incremental growth from a working prototype with mature sections of the program, revised or written many times, providing consolidation, leads to the most appropriate product in the shortest possible time." This explanation I gave to my boss, and this was financial software, was a financial analogy I called the debt metaphor. Shipping first-time code is like going into debt. A little debt speeds development so long as it is paid back promptly with a rewrite. The danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on the debt. If you develop a program for a long period of time by only adding features and never reorganizing it to reflect your understanding of those features, then eventually that program simply does not contain any understanding, and all efforts to work on it take longer and longer. Entire engineering organizations can be brought to a standstill under the debt load of an unconsolidated implementation. The traditional waterfall development cycle has endeavored to avoid programming catastrophe by working out a program in detail before programming begins. However, using our debt analogy, we recognize this amounts to preserving the concept of payment upfront and in full. So, what is he saying? He's saying that it makes sense to borrow money to get started on building by only building from a partial understanding. Okay, so if you have to build a house or you're going to buy a house, he says it makes sense to borrow that money and then pay it back because you get to live in the house. You get started on having the benefits of that house. Okay, so it's worth accruing debt in those particular cases. And he connects this back to software and he says that by doing iterations, you're building something less than the full system that you intend to have eventually. And that gives you the best product in the shortest time. However, he warns us very carefully here that if you fail to refactor aggressively, he even goes to the point of saying rewriting parts of the code. If you don't do that, then the code that you wrote yesterday, when you had a partial understanding of the requirements and a partial idea of what a good solution would be, that code that you're looking at will not line up with the new ideas that you've got, the new ideas about the requirements that you've got, and the new ideas about what's an appropriate design, what's an appropriate architecture, okay? So he's really saying these two things must go together, that you can get going fast, but the way you go fast is by using iterations plus refactoring, and that is a suitable way to do it. So let's connect the concepts inside of the debt metaphor with specific actions to make this crystal clear. There are three parts to the debt metaphor. First is taking on the debt. The second is paying interest on the debt. And the third is paying down the debt. And by paying interest on the debt, I mean sort of the suffering part. And the final thing about paying down the debt is the removal of suffering, okay? So what is taking on the debt? That is when you have a partial understanding, say because you only read some of the requirements or you only did a little bit of design, and you choose to do something a little bit surprising, which is that you ship a partial solution. So perhaps you want a car eventually, but you only look at enough requirements and you only do enough design to build a skateboard. Okay, so that's when you take on the debt, because you know eventually your ideas will change as you understand more requirements. About taking interest on the debt, that is the friction that you and the rest of your team feels as software developers when your code and your ideas don't line up with each other. When they don't line up with each other, you're trying to think in these new abstractions, whether they're new design abstractions or they're ideas about what the requirements are, and yet you're staring at these partial half-formed ideas that you wrote down in the code yesterday or last month or last year, and they don't line up with each other, okay? So until you actually take the time and effort to align those, you're gonna feel that friction. You're gonna be slowed down, and it's gonna get harder and harder to build the next set of requirements if the old code that it's misaligned with those ideas is still in existence. But finally, you do need to be paying down the debt. And Ward says you do that by consolidating the ideas in the code. And what that means is that you want to line up the things that you're thinking about, I'm building a bicycle now, I'm building a motorcycle now, and so forth, with what you're seeing in the code. And that entails refactoring and rewriting. In fact, the original paper didn't use the word refactoring because that was not a word that was in common use in 1992. So let's take a look at the three major software processes. With the waterfall process, we don't need to worry about refactoring or any of the skew. In fact, this is what Ward Cunningham was addressing in that original paper. He was specifically saying, I think it's a better idea to use an iterative process than it is to do waterfall, because with waterfall, you seem like you're doing the rational thing, which is you're getting your ideas all straight up front. But what he was arguing is you're actually going to get started faster, you're going to get benefit from the code faster, you're going to be able to use the thing that you're building if you do an iterative plan, but only if you do the refactoring that's necessary. So let's go back to the characteristics of the debt metaphor, and this time let's attach concrete examples here. So in terms of taking on debt, an example of that is when you only consider the skateboard use case. Okay, you only look at the requirements for skateboards and you come up with a design that's good enough for skateboards and you choose to ship it. It's a bit surprising when you think about it that way. The second part of the debt metaphor is the interest on the debt. And so an example of that might be when your ideas and your code don't line up with each other. So imagine that you're on the final step of this and you're building a car, and you go look in your code and you still have a file in there called bicycle.json or anything like that, okay? And what's even weirder is the bicycle, which of course conceptually a bicycle has 2 wheels, you find inside that file that it has 4 wheels because you've sort of done a halfway job of integrating the old ideas and the new ideas. Just imagine you try to bring a new person onto your project and they are just confused as can be. They come over to your desk and say, we're working on a car, right? Right, we're working on a car. Why do I have this file here called bicycle, and why do we have 4 wheels on bicycles? And you sort of go, okay, let me tell you how we got here. And so that's the idea. The debt that you're paying is when those ideas are not lining up with each other. And the friction and slowdown that you feel in trying to make progress on that code base when your ideas in the code are misaligned. Finally, paying down the debt. Paying down the debt happens when you actually replace the parts of your code that refer to skateboard wheels with bicycle wheels. Like, you can almost even imagine that you could make a bicycle with skateboard wheels, maybe, but you wouldn't want that to last very long. You want to pay down that debt, okay, to actually go through and rewrite or refactor that code. So, what's the moral of this story? This has been interesting to study how Ward originally talked about technical debt and how we think about technical debt today. But what should you do? What should you take away? The first thing I want you to take away is the counterintuitive idea that technical debt can be a force of good, okay? That you want to borrow money, basically, that is, take on this debt that you know is inevitably going to happen, right? We're inevitably going to get my ideas and the code to be misaligned. We're going to borrow money to get started. And what I get in return is I get started. I get to start coding. I start to learn the problem better because I'm down there in the code. I learn things that I wouldn't learn about the problem domain and the solution domain and maybe the technology that I'm dealing with. I would learn all those things. And he argues, without evidence here, but he argues that overall, you're probably going to build a better product in less time with an iterative process, okay? And the thing that you need to watch out for is the failure to consolidate. That iterative development at first is easy, right? Because there's not that much debt, but it becomes harder over time as the difference between your thoughts and the code you're looking at gets bigger and bigger. You're going to experience friction when the ideas don't match the code. The example I used of a data structure or a file being called bicycle when you're working on the car is really the smallest of that. Usually it's these fundamental conceptual things that are really going to weigh you down. And the analogy here is that having a credit card isn't an inherently bad thing. I think that most of us have a credit card, but it's being the junkie that's the problem. The problem is when you don't pay down your balance, and that's when the problem is. So I want to leave you with some of his final words that he wrote in 2009, where he was trying to, perhaps in my view, I think he was trying to course correct what he saw in the writings about technical debt. He said, a lot of bloggers, at least, have explained the debt metaphor and confused it, I think, with the idea that you could write code poorly with the intention of doing a good job later and thinking that was the primary source of debt. The whole debt metaphor, let's say the ability to pay back debt and make the debt metaphor work for your advantage, depends on your writing code that's clean enough to be able to refactor as you understand the problem. So what I see him describing here is, well, you could look at like deliberately writing bad code as a form of technical debt, but that isn't really what he's talking about. He's really talking about this idea that you're striving to write the best code that you can, and that leaves you in the best situation for doing a refactoring when you come to that time. So when I see teams trying to decide what process they're going to follow, it's a bit like deciding which door you're going to walk through. Like what are the choices in front of you? And the questions that the teams should be asking themselves are, do I want to fully design up front and just build it like a waterfall process? Or do I want to buy into the necessary evil of refactoring to match the code in my thoughts? So behind door number one is an okay option, which is either doing waterfall or incremental delivery. And with that, I have to delay when I can deliver the system. I even have to delay when I can start coding the system until after I've done all the design and I have enough knowledge, I've gathered the requirements fully. But the advantage that this has is that you don't have to do any refactoring, right? You can just design everything, and if it all works out, you put it into production and ship it. The question, of course, is always whether your design is going to be correct enough. You may find that you didn't understand the requirements, and then you have to loop back in your waterfall process. The second door is an iterative process, and it's kind of the mirror image. The idea with iterative is that you can start now, you can start delivering now with only partial knowledge. You don't have to spend as much time analyzing the requirements or coming up with the design. But the downside, of course, is that you have to do the refactoring, like it just comes with it. Now, you may say, George, I think I really understand these. You've said them quite enough times. But what I want to emphasize to you guys is that what happens in practice is that people want the door that doesn't exist, right? The choice that is not a real choice. and they get into a lot of trouble with it, okay? They want to start now with partial knowledge because they think they see other teams following an agile process, an iterative process, and the thing is that they don't really want to they don't want to pay the price of proper refactoring to actually drive the technical debt down to zero, right? Or at least a low enough part. And so what I would like to say to these teams is, if you start quickly, then refactoring is inevitable. There is no free lunch. There is no door number 3 that allows me to do iterative development as long as I want and endlessly defer my refactoring. It's like a credit card. The bill always comes due. So something that I've always kept as an aspiration for myself comes from a quote that Ward wrote. He said, "It was important to me that we accumulate the learnings we did about the application over time by modifying the program to look as if we had known what we were doing all along." When I think about the code that I've written, oftentimes, as I've written the code, I've grown in my understanding of the problem and what the right way to solve it is, okay? And when I find that has happened, I like to return to the code and redo it, okay? Now, if I'm in a team environment, that might mean I write it once, I get it working, and I have to do more refactoring before I send it to a teammate for review, okay? So as far as they're concerned, I only sent them good-looking code that indicates that I knew what I was doing. But what Ward is saying here is, it's kind of a charade that we want the code to be in a state that it looks like we know what we're doing. That is, we want that coherence of the design, that conceptual integrity that Brooks asks us to find. But he says that the only way to do it is to actually get in there, make the mistakes, and then repair them. The only way you can really go wrong here is when you think you can cheat death or cheat your debt and just go in there, make a mess, and never fix it up. So thanks very much.